Well, Wade Sal's are unfortunately not here. I should have taken his name off that, but regardless. So I look at for the oil and gas and energy and utility industries for Hortonworks, and want to talk a little bit about what we're seeing from an industrial IoT perspective, from an open source data platform aspect in both industries. So this is pretty high level. Wade was the one that usually covered the technical side, right, from a solutions engineering perspective. But regardless, hopefully you'll get some value out of it. So, we tend to hear a lot about, for those that aren't in, part of the industrial world, we tend to hear a lot about IoT, right? And we think about wearables and, cell phones and, whatnot, right? Fitbits and things like that. But really, when you look at a market opportunity perspective, the industrial IoT landscape and market opportunity is much larger actually than like consumer IoT, right? And there's a number of companies that traditionally you would associate probably with industrial IoT. Maybe Hortonworks isn't one of those. Companies like GE or ABB, Honeywell, people like that, right? But actually, we're seeing obviously a number of industrials, whether it's manufacturing, energy and utilities, oil and gas, that are really pushing the envelope as it relates to industrial IoT, with open source technology. That's what we're going to talk about more today. So, when you think about industrial IoT, right? One of the main aspects of it is the ability to really blend those operational technology data sets along with traditional IT data sets to drive business improvement. And historically those things have lived in very siloed environments, right? Managed by different folks, and typically the operational technology guys, the only reason they talked to IT was when they needed another server to support like a new SCADA instance or something, right? Otherwise, they're like, no, you can't have my data, that kind of thing. And so at the end of the day, though, as these, particularly we've seen it quite a bit in oil and gas with the downturn, is as organizations have unfortunately been consolidated due to the reduction in forces that have occurred, right? You're seeing quite a bit of desire to bring in and blend these data sets. Again, it's not just around time series data, right? It's financial data, it's asset data, looking at work over history, all that good stuff, to start to knock down some of these silos and increase efficiencies and workflows. But at the end of the day, is having better purview into like real-time asset performance, for example. Where are we profitable? Going back 3 years ago when oil went from $100 a barrel to $30 a barrel, we need better purview into where are we actually making money and where do we need to sell, right? What's not a core asset at this point any longer in this new cost model? So this is just a slide from IBM that I stole from somewhere that I just really like, right? In order to truly drive business performance and improvement, there is a need to blend these different data sets, OT, IT. You could even throw in ET, right, on the engineering side. You could throw in external data sets like weather, environmental, social, things like that, right? And that's really what we're starting to see from both our oil and gas and our energy and utility customers. And this is another side from Accenture. They talk about the missing middle, right? And that's just disparate people, processes, workflows, data sets, et cetera. And when you start thinking like a technology like Hadoop, for example, what better technology to truly be able to combine this multitude of data sets, time series, structured, unstructured, video, weather, right, whatever, whatnot, and bring that into a single environment under management to start building applications to really fill in this gap, right? To connect people with data, starting to automate workflows that at the end of the day, really before, weren't possible, right? And so, why open source for industrial IoT? So this is my pitch to the community. Why do we need to be driving standards and open source technology for industrial IoT, right? Or why does it make sense? Let's put it that way. Well, really the tools are there and continue to evolve, right? To develop such a platform through open source technology. It's all it's all there. And I think what a lot of companies have learned through some of these bigger monolithic, proprietary platforms is some pretty hard lessons around scale and cost and effectiveness. Let's be quite honest, right? And it's not just about obviously time series data. If you start thinking kind of the legacy historian-like applications, it's really the ability to manage all of those pertinent data sets, whether they be from the plant floor, from the refinery, from the asset in the oil field, or from the rig, right? But it's everything else. It's all the financial data. It's the workover history. It's video streams. It's weather. All of those things that are pertinent to a process or to a piece of equipment. And really that's what technologies like Hadoop and this, we talk about Hadoop a lot, but right, really the ecosystem enables you to bring all those different data sets under management and starting to work towards not just descriptive, but predictive and prescriptive analytics, right? Cost-effective storage, parallel processing. One of the things that we hear quite a bit is, from our customers that are leveraging open source technology is the ability to really control your data and control your algorithms. It's not just a black box where you're given an algorithm that spits out a result, and ultimately you really have no control over no control to modify it or add additional calculations, different algorithms. And the other things we hear, particularly from mentioned earlier, the OEM suppliers that also are bringing industrial IoT and predictive analytic platforms to market, which is I don't want my OEM telling me when I don't want their software telling me when their piece of equipment is failing, right? I feel like it's somewhat of a conflict of interest. So instead, it's the ability to, hey, I control who has access to my data. I can bring in telemetry from their equipment, and then I can provide them a portal in which to leverage their subject matter expertise and domain knowledge as it relates to their equipment if I need it, right? So really kind of that best of both worlds. I own my data, I own my calculations, but I can still leverage them when I need them. Really, and this is applicable across all industries, that have moving metal, if you will, if you think about it. And one of the things particularly, I think in oil and gas is we're still getting used to the new normal, if you will. We hit 70-ish per barrel here a couple weeks ago, and then like 5 days later it was right back down to like 62 or whatever. Very volatile. Is future-proof. There's still a lot of concern around de-risking adoption of technology, and by leveraging open source and from companies like Hortonworks and how they go to market and adopt new open source technologies and add support, add engineering to those new projects, right? That you're really helping yourself in the long run by de-risking and future-proofing around technology to help solve industrial IoT platform and predictive analytic type use cases. And this is just one of our customers a couple years ago presented at a conference, and I thought he was spot on. It's data is not your competitive advantage. It's the algorithms you build to analyze your data that will differentiate you. And I put this here because utilities tend to be a little more probably collaborative, I would say, as it relates to things like this. Oil and gas has gotten much better, I believe, honestly. That's one of the probably maybe the positive aspects of the downturn over the last few years is collaboration has increased. But there's lots of common data storage, data processing challenges, data ingestion challenges that through development of shared standards via technologies from the open source community could really help streamline and increase efficiencies for a lot of operators. And you're starting to see that more, right? You're starting to see more operators that are willing to, donate code around, again, particularly going and ingesting a particular type of data set, whether it's time series or, WITSML data from drilling or whatever it might be, or some common data processing type issue, common data processing workflows. You're starting to see more of that being shared, which is great. And so, is the energy industry, is it ready to embrace an open model? I mean, I think so. I mean, this is, ExxonMobil, a couple of announcements around their open automation initiatives that have been in the news here as of late, and really a desire to help from a future-proofing perspective, from an economies and efficiency perspective, the ability to not be tied to a particular vendor as it relates to both hardware and software, and when new technologies come up, right, the ability to interchange those and just have better access or being able to leverage new technologies in a more efficient manner through some driving open standards, and particularly with software and hardware that's been around for a very long time as it relates to operational technology, DCS systems, SCADA systems, et cetera, like that they're running in their refineries or upstream, right? You're seeing a lot of that. You're seeing a lot of companies right now. I would say it's more brownfield, right? It's going and getting those data sets that have existed for a long time in historians, SCADA systems, DCSs, and bringing those into analytic platforms and democratizing that data. And then there's a lot of experimentation going on around more the greenfield side, right, which is gateways and things like that. Where can we start augmenting pieces in this operational technology, SCADA, DCS landscape with gateways, with new protocols like MQTT and things like that, right? So it's kind of plug and play right now in a lot of aspects, that's really how we're going to get to where we're trying to go. And so I'm just looking at time here because we're a little bit late. So if you look at where's the focus, where's the investment, right? In from an oil and gas perspective. And industrial IoT obviously is high up there according to this Accenture survey. This was done in 2017. They actually surveyed somewhere around, I think it was 600 VP C-level folks with oil and gas companies. So industrial IoT is very high on the list of their technology and their investment. And then you look at from what types of business challenges are they trying to solve? Asset management, drilling completions, production optimization, capital project management, probably not so much, but 3 out of those 4 really are industrial IoT-like use cases. And this is particularly from our larger customers, whether it's oil field services guys or the integrated utilities, or particularly the large oil and gas companies we work with. This is a very common model amongst all of them, where it just demonstrates the need to. It's not just about internal data sets, but it's data coming from suppliers, obviously data coming from operations, data coming from IoT, or excuse me, from particularly with like an integrated company that has retail operations, refining, et cetera, is bringing all that customer data in addition to operations, in addition to IT, in addition to supply information, into a single data management platform, and the ability to then develop applications on top of that. And then from an energy and utility perspective, some similar stats around focus of by line of business, right? And you look at forecasting, smart meter analytics, asset management. A lot of these are also industrial IoT-like use cases, or and so there's a lot of focus there. And energy and utilities, what better example of IoT, right, than smart meters and just the prevalence of smart meters now. And that's really what's driving a lot of use cases from an open source data management perspective, is how do we ultimately cost effectively store, process, and drive value from 15-minute data, or in some cases, more frequent data, 5-minute data from our customers, and actually drive value not only for ourselves, right, from a operational efficiency perspective, or driving revenue protection use cases, or forecasting, or whatever, but ultimately, how do we better service our customers and provide them the data in which to make better choices from an energy consumption perspective, or have a better ability to actually predict when we're going to restore power when we have an outage, or better not, let's have a better ability to actually prevent outages from occurring, because we're able to manage consumption in a better manner and build predictive models to determine where in the past we've had outages, based on certain parameters, and we have the ability to prevent those. And so it looks something kind of like this. If you're looking from a Hortonworks perspective, you have HDF that powered by NiFi, that's not just something for moving data within the four walls of the data center, but the ability to actually go and get that data from a multitude of data sources, whether it's legacy systems in the control room, AMI systems, outage systems, et cetera. Looking at bringing in third party like weather data, environmental, and obviously the ability to go get data from substations or obviously the AMI network itself, and bringing that into a single platform to then build applications. So there's a lot of talk around time series and emerging time series databases and things like that. It's quite honestly, it's ripe for disruption. There are a couple of big players that historically have owned the data management side from a time series perspective. And really, I think what we're seeing is it's no different than kind of the EDW landscape, right? Where you had companies spending a lot of money on a data warehouse that they then subsequently are now moving that data out of a data warehouse into a platform like Hadoop to then blend with other data sets and build predictive applications, right? The same thing is going on in the legacy time series world where you have these historians that have been around for a really long time, and companies are just moving that data out of those legacy historians into platforms for advanced analytics. And so what's happening is companies are going, okay, well, we're spending a lot of money on this. Is there a way that we can start reducing how much we're putting in them or replace them altogether, right? And due to the prevalence now of IoT and just the open source software community, you're seeing so many new time series databases that are emerging. And this was actually, I'm trying to remember who did this survey. Oh, DB Engines. You can go to DB Engines, you can see the results of this. But just so much activity around time series databases, which makes a lot of sense, right? Because IoT is, Hadoop and big data are dead, and IoT it'll be dead soon too, so don't worry about it. But right now, it's still quite a bit of hype around IoT, so hence the activity with time series databases. So, from an energy company perspective, there are a number of challenges that we're seeing. Again, we've kind of talked about, silo data sets, with legacy applications. In many cases, it's scale and speed, particularly for, the larger companies that we work with. It's simply even the legacy technologies that, have been around for a long time for managing time series data sets, they don't scale, right? They don't scale when you have a million tags in each facility, and you've got 60 of those, for example, right? They just don't scale. Considerable effort to leverage. It's not necessarily they're not easily accessible, right? You have lots of different sources. Like we've talked about. It's not just the time series data. It's also the lab results. It's the workover history. It's lots of unstructured documents from I like to say the one really it's quite simple, right? If you look at an industrial piece of equipment, the time series data is essentially it's the heartbeat, right? It's telling you those signals are telling or indicating the health of that piece of equipment. So if you have that information, and then you have information relative to failures and when they occurred, and then all the supply chain information, what actually failed and what you replaced. And then you have emails and notes around, from the folks that actually went out and did the inspection and the workover. You really have this entire lineage of data around, why a piece of equipment failed and the signal associated with that, right? And so if you can bring that into a single platform over years worth of history, and it's not just a matter of a single piece of equipment, it's a manufacturing facility that's making the same widget or the same process, right? Whether it's a chemical or a fuel or a lubricant or something, and you're doing that in multiple locations with the similar equipment, you have a lot of information at your disposal that you can bring into a single platform and actually start seeing that single view of these processes where, again, those processes are the same, and start, building out that history of data and the ability to then start predicting when you're seeing similar anomalies from one place to another and reducing the propensity for failures. And in a lot of cases as well, it's just a matter of getting those data sets into a platform in which you can apply, democratize it, right? We hear it all the time. I've got my Pi system, data scientist wants access to Pi. The Pi admin doesn't want to give it to him because there's only so many clients and they've already burned all their clients. And so he just gives them an export and here's some data and, go off and we'll fight about it next time. That's not how, the data scientists want to work. They want all of it, right? And they want the ability to deploy their models and get results very, very quickly. So we're just seeing a lot of, hey, how do I get data out of my legacy system and get it into an environment in which I have access to all of it to run my algorithms? So, obviously we've talked about the importance of time series data, extremely high value in an industrial landscape, right? It's indicative of asset performance, which is really the lifeblood of an industrial operator, whether it's oil and gas or manufacturing or energy and utilities. And so the challenge has been kind of this, right? That we just have this spaghetti web of mess of points of integration, right? And going and getting data from the SCADA DCS landscape, in the case of an oil and gas company, drilling data, getting data off the web, video streams, whatever that might be, right? It's looked like that. And, the open source community, we initially saw things, fairly well. It's continuing to evolve from a data management perspective. Hadoop is the environment in which you can bring all this stuff in, structured, semi-structured, time series, et cetera. And you have an environment in which you can store it fairly cheaply and process it and analyze it fairly quickly, right? With lots of different tools. But there was still the problem of actually going in and getting it, and that's where NiFi solves a lot of challenges for a lot of people. And for those who don't know much about NiFi, it's a great data pipelining tool for getting not just Twitter feeds. That's where a lot of demonstrations of NiFi occur online, and the SEs use it a lot because it's always on. It's always producing data. But Twitter feeds, click streams, and relational data sets and video and all kinds of cool stuff. But what happened was that this aha moment has started to occur with the industrials, where, hey, I can go get my time series signals from my SCADA server that's out remotely at a site that's not within the four walls of the data center. Or I can go get it from my drill ships out in the Gulf of Mexico, because it has a great ability to compress and encrypt data and move it across a low latency connection. And so that's really, again, has been the aha moment for doing this, right? And it's not that you have NiFi like sitting on a PLC somewhere. Maybe someone's doing that. Most of what we're seeing is what I've been talking about, right? Is you have a server running NiFi alongside of the SCADA server, the DCS server. In some cases, we're starting to see where NiFi is being leveraged and deployed on like IoT gateways. Like I call them the pizza boxes, but like the Edgeline servers from like HP, Dell that they're throwing out there now, right? But in most cases, we're leveraging like an OPC connection, which has been around for a long time, where the community has built out a processor. It's one of the great things about NiFi. Is extendability, right, from a processor perspective. So we're seeing that with like OPC, for example. We're seeing that with Modbus. We're seeing that with WITSML for getting drilling data. So taking this, Joe Witt's tool that he had no idea was just this, basically it's just a really awesome polling engine and now it's, we've made it dirty, basically. He built it to go get Twitter feeds and stuff, and now we're, going and getting control systems data, which is really neat. So let's talk about, we already went through that, I said that twice. Let's talk about some use cases. So, what are some typical goals from an industrial analytics practice? I mean, there's a number of them. I should have Kevin probably talked about this yesterday. I should have him come up and talk about this. He's the smart one. Him and Wade get along really well. But obviously looking at forecasting, anomaly prediction, filling missing gaps, right, interpolation, all those things that the data scientists want to do to help their, to help their fellow industrial brethren out that actually run the plants and refineries and upstream operations, right? They come to them with a business problem, and why are we having these weird failures occur when it doesn't make any sense, right? Things of that nature. And again, for very large companies, scale and speed is still a big problem, and that's just classical Hadoop, right? The challenge in the past has been, how do I go and get near real-time data on 500,000 tags from a remote piece of equipment? Well, that's where NiFi has solved that problem. Particularly, again, it's not just going and getting it, it's moving it in a cost-effective manner and also doing it securely, right? And that's where, I think industrial IoT still has a really long ways to go. And you're going to start to see more and more that are standards around, particularly the security piece, to where, these different devices that are generating or holding, different data sets ultimately can start talking together in a more secure fashion, right? So, just a few use cases. This is, when you talk to companies that have an advanced analytics program in place, you'll hear them talk about kind of those long-term, big projects that they're working on, right? Trying to get to an application that they're delivering in a, to a multitude of people in a production fashion. But along the way, these one-offs kind of come up, right? And they're great opportunities to, prove to the executive sponsors that you can actually deliver results from an investment in open source technologies and from a data management perspective and advanced analytics, right? So this was actually a utility company with a very large solar farm that kept tripping offline. And they couldn't figure out what was going on. And so they engaged us and they gave us somewhere around 5,000 tags from their historian, and I can't remember, how long, what the time window was, but essentially it was, here's data, from the asset. Can you help us, find out what's going on? And so, long story short, one of our data scientists at the time came back and said, all right, when the plant trips offline, here are the 19 tags that are showing anomalies, the signals. And the guy was like, that has nothing to do with why the plant is tripping offline, but we'll investigate it anyway. And so they did, and they came back, and what they found out that there was actually a valve that was installed backwards, and so when coolant was supposed to be being brought in to the facility, at high demand rates, it was actually going the other way. And so the facility had some overheating issues and it was tripping offline. So in that case, it wasn't a big exercise, right? It was like a 2-week engagement, and it was millions of dollars were saved, right? Because when that facility shut down, they had to go and spot buy energy to deliver their customers. And so, great win. That didn't require like a multi-million-dollar investment, but it's just a great example of how data science can solve complex problems pretty quickly when it's used correctly. So this is a vertically integrated utility. This is actually a time series. Well, it's a AMI data use case, right? So again, scale and speed. One of the big challenges utilities have is with theft. So they estimate somewhere between 1% and 3% of energy, or I'm sorry, of loss. Revenue due to theft globally for energy and utility companies. In underdeveloped countries, it's actually closer to 3. Here in the States, probably 1.5. And in this case, this company, prior to investing in Hadoop, was typical kind of data science process. They're running their algorithms on outputs, from a relational database, and for a particular service territory, it was taking them quite a bit of time to actually comb through and generate theft leads. And and so it's not just a matter of identifying, customers aren't always stealing electricity, right? So there's time to value there. not just the ability to identify a theft lead, but do it in a timely manner in which you can go and investigate it. And so they've actually now, for that particular service territory, they were able to reduce what used to take them a number of weeks into minutes, and now are moving all their AMI data into Hadoop, and they've seen a multi-million-dollar return on their investment from their revenue protection use case, just by, again, scale and speed, right? Democratizing that data for their data scientists, and allowing the compute to do what it's supposed to do, right? Which is crunch through numbers and identify theft leads. And it's really interesting, we were talking to them, I didn't realize it, but you actually, to truly take somebody to court, you actually have to catch them doing it, is what they said. So they're actually they actually have to not just predict when someone's doing it, but have a pretty good idea of the time of day in which they're doing it in a pattern so that they can send a truck out to go check it out. I didn't know that. I thought that was really cool. I'm thinking like back in the day when they used to put a magnet on the wheel that was spinning, right? That's how they used to slow it down. That's how they used to, but they were telling us lots of crazy stories about how the lengths at which people will go to steal electricity. So this is actually a customer story. It's on our website, and we actually have a gentleman here from Rowan. You want to come up and talk about this? No? You sure? All right. So Rowan Companies is an offshore drilling company with a number of drill ships and jackup rigs spread out throughout, 22 dozen-ish these days? 20, 25, 26, isn't that about right? Somewhere around there. And this is just a great NiFi story of the ability to go and get data. I mentioned earlier in a highly low latent environment in a very small pipe. So essentially, drillers aren't making money if they're not drilling. And at the same time, right, as you're changing crews over, things like that, there was a desire to have better purview into those data sets, back in the home office. But the other big thing was, as a result of Deepwater Horizon and Bessie, was the regulatory aspect to actually have near real-time access to data being generated from the drill ships and rigs back on shore. The ability to store that long-term, right, and to start building predictive capabilities so that something like that doesn't happen again. And the biggest challenge with this is these things are all over the world, and it's a very, very expensive small pipe in which to transmit data via a VSAT connection back on shore. And so we went through a proof of concept where NiFi was loaded on a laptop and taken on a helicopter and dropped on one of the drill ships and tied into the control system. And I said, Wade Salazar, who unfortunately couldn't be here, our SC, he deserves the credit here, went to hacking away on a keyboard, and all of a sudden, we're bringing in data from 5,000 tags from the middle of nowhere. And when you talk about scale, right, and you hear about some of we talk about just big picture of the industrial IoT platform landscape, and you hear horror stories around the amount of time it takes to roll out new assets in some of these other platforms. In less than a year, Rowan was getting data into the platform and starting to build out applications from all their assets spread out throughout the world. And the really great thing was, one of the really cool things was ultimately our NiFi's ability to compress and encrypt that data, some of the money we saved them from moving that data actually back into the cloud, and doing a number of interesting things from an application side of the world to drive additional value to the business. And lastly, in conclusion, right, we are at DataWorks, and we're all passionate about open source. So I encourage you to collaborate with your fellow companies within your industries, help drive some standards from the open source perspective. Again, the value is in the algorithms that you deploy on your data. That's your IP. So if you have the ability to share, code and processes and things like that, it obviously empowers everyone to have, to do things more quickly and to drive value for everybody. So with that being said, thanks for coming to the conference. Thanks for attending my session.